Oh, hey, what's happening there, YouTube? It's Brian House here for Housework, and today is the day. We have spent the last couple of days assembling and figuring out all the wiring and everything for the Langmuir Systems Crossfire Pro. My son Dexter, who just so happens to be kind of an expert in the whole X, Y, and Z axes thing. He's built numerous 3D printers in his very short life. He is 14 years old. And this table is essentially a very large version of a 3D printer. And so to have his assistance was pretty awesome. And he knew what he was doing. And I kind of went along for the ride and assisted in just double checking everything. So if that gives you any frame of reference, a 14-year-old person can, in fact, build a Langmuir Systems Crossfire Pro, which I think is actually kind of cool, right?
Yeah.
Did you find it? Come on up. Did you find that what the process was? It similar to 3D printer, and did you think it was difficult?
I didn't think it was that difficult, and it is very similar to 3D printers, but it's obviously different because it takes away than putting it down. But
the concepts are the same.
Yeah, with 3D printers, it's usually the bed moves instead of the whole y-axis. Yeah, I think, yeah. And then the head usually moves the same way as this does, and everything's basically the same. It's just there's obviously some differences between the two.
Cool. We actually spent all day yesterday getting the plasma cutter plumbed up. There's a couple of core pieces that need to be installed along with the Crossfire Pro and the Razor Weld 45, which is the recommended plasma torch setup for this table, although I have seen people use hypertherm and all different kinds of torches with this setup. We just went with the Razor Weld version because that's what Langmuir actually recommends. So we plumbed it up, and then we plumbed in a dryer, an inline dryer that went after my dryer that's on the compressor itself. So there's an additional layer of dry air coming into the machine, which I have read and have had many people approach me about and say that's super important. If you want good clean cuts, you got to have good dry air. And so we went ahead and spent a little extra money and got the nice air dryer system for it. So yesterday we plumbed the whole thing, we got it all kind of put together and ran our first test cut. It was an exciting test cut because it was something that I had been working on in the previous video, which was the platen bracket. I had never put together G-code before, so this was like a whole new experience for me. Fusion 360 is awesome, by the way. It has a whole manufacturer component in there that allows you to draw tool paths and then ultimately export it into G-code, which the Crossfire can read through a piece of software called Fire Control. There are all kinds of tutorial videos on the Langmuir Systems website that walk you through this process. And once you start understanding the core concepts there, it becomes relatively simple to set up a path so that it can cut something out. Then, of course, you've got air pressure and amperage and inches per minute and all these other things that you kind of have to factor in. And there's a chart that sort of puts all that together for you because it's all different based on the thickness of steel that you're cutting, or the type of steel even. So yesterday was our experimental phase. We ran one cut, and I feel like it went really well. It was a good cut, but there was some issues. We didn't have enough air pressure, so there was a lot of slag and dross on the backside, and the pieces didn't fully come away from the cut. So we think we have that fixed now. We actually haven't run this new set of code yet, so we won't know until we run it. But I figured, you know what, let's bring you guys along for the process of this so you can actually see it. And I'm not going to edit anything out, so if the cut fails, you'll see that too. So anyway, are you ready to do this? You want to try to cut it?
Yeah.
You got the machine zeroed out?
Yeah.
So it's like ready, right?
Yeah.
So take me through the process. Now we've got the G-code is pumped into Fire Control, right?
Yeah.
And these are the tool paths that we're looking at here?
Yeah, these red or orange lines are where the torch is going to go.
And the blue line is where it's not going to cut, right? So that's where it's just traveling across to get to where it needs to go.
Yeah.
Okay, and we've got everything zeroed out. Looks like Z is not zeroed.
There you go.
Is it all the way up?
Mm-hmm.
Okay. Good deal. So, all right, well, I guess this is it. And we hit start and it'll start cutting.
Yeah.
You feel confident? You got all your settings correct?
Hopefully.
Check your amperage. Check your air pressure. We're at about 55 PSI and we're at 30 amps. And it looks like we're all set there. The water table is leak free today. We had to drain it yesterday because we had a small leak. So, all right, let's do it. Little bit of slag on the back end.
It's a lot better though.
A lot better. This one piece is like all kind of crooked in there a little bit. This one looked like it cut okay.
Yeah.
Not too bad though. These are really small holes too. So this is a pretty small part. The cuts are pretty clean, but it's leaving a little bit of slag or dross. I'm not exactly sure what you call that on the backside there, so we need to figure out why that's occurring. Most of it seems to chip right off. It just kind of comes off in a chunk, but like this one would be, that's trouble. We need to fix that. And then this little guy here, it's kind of hard to see, but it's off. Like this side, it looks like it compensated just a little too much on the one side. It's supposed to be the same width, and that could be part of my coating issue there. And then another slight imperfection here. We kind of have to play around with it a little bit to see what's happening there, but overall not too bad. I'm gonna clean these up and see if they fit together. Okay, so I tapped it with a hammer, and this actually is what it looks like after I just broke that off with a hammer, and that's actually pretty acceptable in my opinion. I gotta read up on why. Did you break it all off of that piece?
Yeah.
Oh yeah. So we need to figure out why the cuts aren't super. I mean, they look pretty straight, right? Not terrible.
Maybe you'll have to drill out these holes, but
Yeah, those holes are really small. They're 0.3. Not too terrible. But yeah, this like these little pieces of slag, they just knock right off with a hammer. You can just there it goes. Comes right off. Clean up on the belt grinder and away we go.
yeah.
Let's see if we can assemble these pieces. I don't know if that one's usable, honestly. It might be.
Look at that. Pretty close. Oh, there you go.
Oh man,
Just gotta like
it's just like the drawing.
slide it in there.
This needs a little cleanup.
Yeah.
Let's see.
Looks really good.
Yeah. Let's clean them up, see what we can do. All right, so we spent the better part of the day working on these pieces here, trying to figure them out. There's a whole bunch of them that we cut out that weren't right, and what I've learned about this plasma table, probably every plasma table, that you need to have the table level. And of course, there's other settings like inches per minute and how much amperage you're pumping into it and so on, and how thick the steel is and yada, yada, yada. But ultimately, this is right off the table. This piece over here has been cleaned up, but this one here is right off the table. Just knocked the slag off the bottom of it, or the dross off the bottom of it, and I feel like that's a pretty good tight fit for a plasma cutter there. And the cool thing about this now is I feel like I'm getting more comfortable understanding G-code and how fusion works. And then of course I had to take this is the other pieces that we cut, and we cleaned them up a little bit with a grinder, and just wanted to file out some of the little corner in here. And yeah, the fit is really nice. Looks really good. The one issue I am having is these are the platen backers. The holes are sloppy, and I think there's not a whole lot I can do about that. I don't believe this size of this hole is something a plasma cutter can really do. Could I live with that? Yeah, but this would be better cut off at a laser cutter, or you cut the piece without the holes in it and drill the holes in it. Now this was the last piece we cut, and you can see here that is a very clean looking cut. Very little slag. There was just a little bit I had to knock off with a hammer, and that looks really good. But it is slightly too small. I don't know how, but the plasma cutter is compensating in some way, and this piece is supposed to be 2 inches by 11 inches, and it's actually 1 7/8 by 10 and 15/16. And for you metric folks, try to wrap your mind around those fractions. It's not easy on our end as well, but for most of us Yanks, we understand it pretty well. But anyhow, so the concept that this is just a little bit too small doesn't bother me, because this is literally a backer plate. It doesn't hold any other. It doesn't need to be quite that big. It just annoys me that I cannot get it perfect. I wish I could get it perfect, and I'll have to adjust the G-code, play around with my kerfs and so on. But yeah, for the most part, it went really well. I'm gonna pop a couple of welds here on these pieces, and see if we can actually make this thing into something. Something kind of cool about using a really strong magnet to hold your work pieces. This will also magnetize this piece just slightly, so when you go to set these pieces onto it, they stick. Not that it's perfect, but it's pretty dang close. Just gives you an extra little bit of help when you're doing it. Well, all right, so we've managed to achieve what we wanted to achieve. I spent a majority of the day fiddling around with the plasma table, trying to sort out the different alignment issues, and I learned a lot in this process. You know, spending 8-9 hours on something that seems frustrating, but you know at the very end when you get there, you're going to be, sort of slingshotting yourself for future success and also time efficiency. So I felt like it was a necessary evil to kind of level the table, figure out G-code, figure out how fusion works and kerf works and plasma cutting. And you know what? We made something today, and this is pretty cool, man. And to take something, draw it up in Fusion, and then sort of conceptualize it there, and then to see it come to fruition in true cold hard American steel is just a thing to enjoy, man. And it's not perfect, it's got a little bit of a twist in it, just a slight twist. We can fix that, but for the prototyping concepts, the ideas that we can take something, design it, and then send it to a CNC machine and print it is now here. We can now do that. So the possibilities are endless in my mind. This project needs a little bit of refinement, I think. I ended up using all 1/4" steel. I thought initially that I would use 3/8 steel for these pieces here, the brackets that hold the back plate on. But I think I could do it in 1/4", and especially when I cut this backer plate, I realized this thing ain't moving. It's in there. There's no play in this thing at all. Fabrication wise, it went pretty easy. Just as I thought it would. It's not a difficult weld together process. Plus the way I designed it, it gave you nice flat surfaces to pop welds onto. As you can see there, I just laid up a couple more welds. And when it wasn't straight, I took a hammer and snapped it and, smacked it and, got it back into place. So I feel like, all in all, this is a success. And I am excited for the future and all the things that this brings with it. All the technology that we can now compile our ideas and pump out new and cool stuff. So, listen, if you got something out of today's video, make sure you hit that thumbs up. It really does help. And if you're not already subscribed, hit that subscribe button. And if you hit that little bell, you get a notification every time I upload something to YouTube. There are many ways to support my channel, and by far the best way is to go to my website, housemade.us, and purchase the plans for the Revolution. If you've already done that, you need some pieces and parts, and soon we will have merch up there. You can buy stickers and t-shirts and all kinds of cool stuff that's coming down the line there. And man, I am tired. It's been a long day, so I'm going to go home and have a cocktail. Listen, guys, I hope to see you on the next video. My name is Brian House, and this has been Housework.